Let me see. The mouse works. Okay. I just it.
Yeah.
First of all, let me quickly go to the schedule. Shall we share this now? It's a little bit blurry. Is that me?
What?
I mean your connection.
Connection?
Do you see me like blurred as well?
Bluetooth. What Bluetooth? I didn't understand.
Okay. Well, let me share screen. Can you see the screen currently?
Yes. Yes.
Okay. Mechanical design. Then okay, have some work to do here. Let's go. This week is about machine. Let's go to the grading criteria. Because this is a group assignment, this. You will do it? I'm not sure. Because this, as I said, this is a group assignment. This you have to act as a group. And this is 1 week in the cycle. I mean, in terms of grading. You have 2 weeks to make this, but the result is after the second week. So this week now, what we have to do is to make the physical machine without motors and automation. And then the next week, we are going to add motors and controls to it. So this is what they are going to grade you. And this is what you have to self-check, self-evaluate if you have done this. So let's see what you have to check. Is have you explained your individual contribution? This is important. You have to explain what did you do in the group. You don't have to make everything. Maybe someone will 3D print something, another one will do the programming, another one will do the hardware, the milling, another one will assemble, another one write the documentation, another one design. You can split tasks, but this is what they are going to also evaluate. Like how do you divide in your group your tasks? Then you also have to make a group page. You have to explain your contribution in your page. And then you have to create another page here in the, for example, here. In this page, you have to create here a machine assignment page, somewhere here. And this will be the group page for beginners, for example. And then in this group page, you have to show all of this. Show how your team plan and execute the project. And one has to be leading this task, one of you. Maybe your individual contribution is just documenting this. How you team plan and execute the project, how do you describe the problems, how your team solves them, list future development opportunities for this project, and include your design files, hero shots, and all of this. Okay. This is what you have, and this is what they are going to evaluate. And be careful, because this this is an individual evaluation. Like they are not going to evaluate you as a group, because otherwise, if it fails, you would fail as well. But in real life, if the group fails, you fail. That is the reality. So, but they are evaluating like you, like this. Like if you are able to work and communicate effectively in a team, as well as independently. So you have to show this in your documentation. When you are writing your individual contribution, and they will read your team, your group page, they have to see that you are able to work and communicate effectively in a team, as well as independently, that they already know, because your past assignments. That you can design, plan, and build a system, like you as a group. Maybe you have a no here if you fail as a group. That you can analyze and solve technical problems. So you have to somehow explain those problems, not just showing the final product. And also, you have to be critical with your design. You cannot go there and say, oh, my design is perfect, my machine is perfect. You have to identify and recognize what you did wrong, and how could someone that wants to continue this project, they could improve the design. Okay. So this is the grading criteria. You have to focus on this when you are doing these 2 weeks assignments. And now let's go to divide the work. So being an ashram, there are 4 people. You are one group. Okay. Koshi, you are one group. You have to make one machine. Being an ashram was machine, one machine. And then let's see. Among the active students, you are 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. Except for Paul,
Yes.
you are all
and Kavita.
more or less active. So you are going to make 2 groups here.
No.
3 groups. No, 3 groups will be too much.
Oh, Kavita is not here, yeah.
No, she does not work.
Correct?
I mean, she's not here this week. She won't be here this week.
It's a
Who?
group. 2 weeks. Next week.
Nothing. Yeah, no.
Anyone talking? Yadu, were you saying something?
No.
We're having an internal discussion. Internal.
Okay. So hold a second. I'm gonna hold a second. You are going to make 2 groups. Okay? In 3-bedroom.
Tahu.
Sorry, I got a cold.
Okay. Gagas fans ini. Cerita.
So let me explain the rules of the group. I will make the group. Someone please write down.
Okay.
Yes.
Mm, team 1
Yeah.
and team 2.
Yeah.
That we know.
No, it could be A and M. But it's 1 and 2. Okay. Sibu team 1, Yadu team 2.
Expected that.
Yasil team 1, Safwan team 2. I am deliberately separating people, as you can see. Nadim team 1.
No, separate Nadim and Jasil.
Thank you. Nadim team 2.
Rashid team 1. Yeah, Rashid team 1.
Rashid team 1.
Yeah.
Then Vinod team 1, Vishnu team 2. Puneet team 2. Sarat team 2.
Everyone to team 1.
Yogi team 1. Kavita team 2. Who is missing here? Nisha. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Ah, because you are 13. So Nisha
Which team has less number?
team 1.
Nisha and Paul, team 1.
Paul is not, but
Paul
not
is
a part
not
of the
here,
team.
but it's okay.
Let me take a note of this. Wait, let me check. So can you tell me again what is the team? I said one.
Just
Yeah, the team one is Shibu, Jasil,
Oh,
Rashid,
sorry.
Rashid.
Rashid, Vinod, Yogi, and Nisha.
And team two?
Team two is Yadu, Safwan, Nadeem, Vishnu, Puneet, Sharat, Kavita.
എന്ത് ടീമായിട്ടൊക്കെ പോയില്ലേ പോയില്ല.
So in here you have Vishnu. This is mechanical. Who else is mechanical?
In first team,
No one.
team one,
Nobody else, I think.
Nobody else has mechanical engineering?
No.
പോയില്ല.
Mm,
Actually, in the fab only one mechanical guy is here.
3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7.
Anyway, one team.
Shibu is pretty good in mechanical, and he's physics guy.
So Puneet, you are in both teams.
In both. Okay, that's that.
So
That's
we have 1, 2, 3, 4, 5, 6, 7. There's 7. Okay. Or who said you is good with mechanical? Shibu?
probably Shibu. Yeah, he's a physics student.
Shibu?
No, I'm not. I have a background in physics, not in mechanical engineering.
But you make machines.
Yeah. Okay, let Puneet be like shared resource. This was fine.
So because Puneet is in both teams, maybe he will be the project leader.
There'll be two project leaders, like
It doesn't matter, Frank. We are all here, so it doesn't matter in which team we are in. Like we will share things at the end of the day. We'll ask each other's help.
We'll see.
It's not a competition.
No, it's not a competition. It's because a 10 people team is very easy to dilute the work. Like 3 people will do all the work, and 7 people will just look. So I want to divide this in two, so you all have the opportunity to work on this. So you have to make 2 separate machines. Okay? Then one person has to decide, because I mean, one of you has to decide and sketch what is the machine they want. I mean, you have to be the customer. So in this case, I think, Yogi, because you are not here, you are the customer of team 1. You have to decide what is the machine you want and sketch it, and pass it to Shibu, who is your team leader. Shibu, you have to make meeting with your team and explain them what is the Yogi decision, so you can start working on it. Then in this team,
No.
I'm gonna say it's gonna be Ishnu. Ishnu, you are the customer. There will be
Nice.
more things than that.
Nice.
But you are going to decide what is the machine you want and sketch it. Make it a sketch and pass it to Puneet. Puneet will talk with all the group, will gather all the group and explain what is the machine you want to do. Then there are two rules. You cannot buy anything at all. Meaning for mechanical stuff. Not electronic components you can buy. Electronic components you can buy. Let me see.
Frank,
Yes.
we don't have threaded rods or smooth rods to make the stages, mechanical stages. So we have to buy them. We have the steppers.
Yeah, I mean mechanical. Is a motor considered a mechanical thing?
No, the roads. Threaded and smooth roads.
Sorry again?
The roads.
The shaft
Rod?
of yeah.
Shaft and roads. Threaded one.
Yeah, rods.
Yeah, we
Rods,
should buy
no,
that.
no need
We
rods.
should have it.
Only. We can make a linear state. We can make a linear thing. That is possible, but threaded rod,
Threaded we need.
we don't need. We can use
Like belts.
belts.
We don't have bells either.
Yeah, whatever you.
We can use a thread. But thread is not that very good in tension.
Okay, salvaging seems good. We can do that.
Salvage.
What?
You have to fabricate or salvage mechanical stuff, right? So we can salvage.
Yeah, you can sell it.
Okay,
Printers, broken printers. Just don't break anything to salvage.
We have two printers here.
Just you can salvage a lot of things from.
Actually, Shopper does all the all the parts. Let's salvage it.
Yeah. Shopboy, yeah. Okay. And the second rule is for the customers. It has to be some interesting machine. I mean, not a CNC or a machine that makes something useful, not a general purpose machine. So, Yogi, you are over there. Where before? Yes. You have this role. You have to decide what is the machine you want to build. And you have to make a sketch and pass it to Sibu. Understood? Take into account these two rules, because you cannot buy anything mechanic. If you need bearings, either you fabricate them or you build them. Okay, you do. Yogi, you are mute again.
Yogi, you're mute. We can't hear you. Get over to your phone. Left.
I see a lot of people today here in Trivandrum. Where is Kavita? Is she here?
No, she went for vacation 1 week.
She went to
Ah,
Bangalore.
yeah. Then yeah, he has to be something that needs. Let me write this down. Is any other people remote? Like it's not in the lab from either team?
Nisha has not joined right now. She's here, but she hasn't joined.
She didn't enjoy.
But she is in Trivandrum.
Yes.
She's in Trivandrum.
Okay. No, I mean we need to find a task for the people. I mean you put it and you see. You have to find tasks for the remote people that can be done abroad. Maybe design tasks or documentation tasks. Okay. Yogi, we still don't hear you. I don't know. Before you were able.
Can you hear me now?
Yes.
Can you hear me now?
Yes. Yes.
Okay.
Yeah, we can.
There's something wrong with my computer, Basab. I'm dialing from my iPad now. Cool. So my question was, would the ANSI draw be a boring machine, or is that okay? The drawing machine.
Drawing.
Yeah, the drawing machine is something okay. It's like the fallback machine for everyone. I mean, everyone that doesn't know what to do.
Okay, so I'll
they
think of
do,
something else. If I can come up with something else, then.
Frank, what
Again,
about
what machine? You already have an idea, Yogi?
No. I think we'll discuss with the team also, and we'll come up with something. If the team also has some ideas, we could figure out.
What about foam cutter?
Sorry.
Foam cutter, polystyrene cutter.
Repeat that. Okay.
Thermocol cutter.
Okay.
Hot wire.
So let's actually sync up after the call, and we can go through some ideas.
Okay.
Let's not do it on the call right now.
Okay, then when you decide your machine, okay, when you decide your machine and you make your sketch, someone has to take the lead on the design. One or two people, they have to take the lead on the design and design all of these things that you probably are going to need. Depending on that, maybe you need more people like on the design. But maybe if you need to design gears or timing pulley belts for a timing belt you have found, all of this, then for this you can use some resources like in Thingiverse there are some OpenSCAD generators for timing pulleys, for some stuff like this. You can use all of this and modify because these files are oh, it's not loading. You see there's OpenSCAD archives here that you can use, giving credits or modifying this, whatever. You don't have to reinvent the wheel and redesign all the parts you need. You can use whatever other people are using, but you can redesign like for the things you find. But it is important that you fabricate all of these things, not buying. We don't buy these things. What is the point of digital fabrication then? You will find that the precision of these things when you fabricate them is not going to be that good as the parts you will buy, but it shouldn't have to worry you, because as the time progresses, you will be in the end creating parts that are as precise as the things you can buy in a factory with digital fabrication. But you have to design or modify a design for them, or adapt a design. So the skill you have to get is in the design field. The fabrication, now we have these kind of machines that are not very precise, but then you can improve that in the future. But the skills that you get in the design will be forever. They will not change. Then other parts like the frame, you can use the shopbot for making a big frame for that machine. I don't know what is the machine, depending on the machine what is, you can use the shopbot. Some parts well, here you will have a lot of components that you can fabricate. This is only for 3D printing, but I have never been able to fabricate these timing belts. But I see someone here has been some kind of luck with this. Well, I don't think this is very precise, because this will be elastic. And a timing belt shouldn't be elastic at all.
We can use a thread actually. A steel wire.
Thread?
Yeah, a steel wire also. You know, like the Core XY uses.
Like the Modela, you mean?
Yeah, like the Modella. Do you know what it is called? I'm very interested in that mechanism.
Yeah. Then let me write another rule. Minimum.
HP Paul has a lot of thread rods, smooth rods, timing,
Get
everything.
Get used to it. You're not buying, right? You're not buying.
Has to have two axes apart from the end effector. So the end effector cannot be considered another. Sorry. Then someone has to take the lead on the design, and you will start fabricating this thing. So I think Sibu and Punit, you have to lead this design if you have experience in making machines.
Yeah.
Whoever Vishnu and Yogi, don't make the machine too complicated. And also Vishnu and Yogi, you have to put a price to this machine. I mean, how much would you pay for having this machine? So this must be something you would like to buy eventually. How much would you pay for? And the rest of the people you have to tie to this. You cannot make a machine more expensive than this.
Okay.
Then no, it is not. No, it's here. Lights, couplers, yes, mechanisms. Okay, so let me stop sharing this now. Okay. So first thing you must do. By the way, where is Kochi again? Are they Yadu?
Yeah. Kochi. Let me call and ask.
Okay. Then Shibu,
Yes.
can you explain what happened yesterday?
Yesterday,
What happened?
what are you talking about?
About
Conversation in river.
what?
Don't lead him.
I think.
No, we are having an internal discussion.
No,
The-
I didn't get you. About what? What are you asking about?
About the assignment review.
Yeah. What happened?
Yeah, and they're not there with Kochi, Arshina.
Oh,
She's not
Arshina.
Oh, Arshina.
No, it took time for Daniel to respond. By that time, Neil had moved, and then Daniel was thought it better not to respond.
Arshina was not there in the Kochi lab itself. So Daniel wanted to reply, and by the time Daniel could do it,
Me.
I see. Check something.
sometimes there's a delay, you know. It has happened
Yeah.
to me. The last part of the lecture, I was trying to get attention of Neil, and I was speaking, but I mean, Ekika was receiving the audio, but it wasn't able to transmit it.
So like after Kavita spoke to Neil, we didn't change any settings. We didn't do anything after that. So, even though Punil couldn't speak.
No, we hung up and then I dialed again because the video quality was very bad. And then it went away.
Okay.
Kochi will connect now.
Sorry?
Kochi will connect now.
In a while. They'll connect in a while.
Okay. Then, so Arshin and Dintis, they are very late in the assignments. Binya Ashram, in your team, let me check, I have it in here. Prashant.
Hello.
Akshay and Yogesh.
Yeah.
Is any mechanical there? Is Prashant mechanical?
Sorry, there's no one from mechanical.
No one.
No.
You are Akshay. You are electronics.
But Akshay is good at mechanical.
Is good at mechanical?
Yeah. Hello Akshay, please unmute.
Yeah, Francis.
So you, Yogesh, you are going to be the customer. You decide the machine.
Okay.
And sketch it.
Okay.
Pass it to Akshay.
Okay.
No, to Akshay, no. Pass it to Supriya. Supriya is in lead of the design. With Akshay.
Okay, fine.
Okay. You are separated. You are not both in beginners.
Correct, yeah.
Then.
So actually we were thinking of making a group of me and Akshay and working on a different machine, and the people at Vigyan Ashram like Supriya, Prashant and Supriya and Prashant will make a group and will make another machine. Is
I
that
don't
doable?
recommend that.
Okay.
It's too small, the group.
Okay.
I want to see cooperation between more than 2 people.
Okay.
Even if you are not in the same place, it will be okay.
Okay, fine. Yeah.
Actually, it's good that you are not in the same place, because you will make teams, international teams in the future, and you cannot be all in the same team, but you have to divide the tasks. Someone will make one thing, someone will make the other thing, but you have to cooperate, even if you are not in the same place. So meeting with okay, you all make one group.
Okay, sure.
Then let me see, is whenever Kochi connects, please to tell me. Okay.
So, Francisco,
Yes.
yeah, for the timing build that you're trying to fabricate, so I have one idea about that.
Yes. What is that?
Yeah, so we can make wristwatch like belt. The each link is
Uh-huh.
created by 3D printer, giving some bump or attaching a bump like timing belt itself, and creating two holes at the end, and that we can connect with using pins, and that can be work as timing belt, and which is not elastic. So,
Yeah, but what this for what machine?
so no, general purpose time belt.
General purpose.
Yeah, so you can use it in any machine, and then we can modify it according to our requirements. So that
Yes,
we don't need to buy timing belt we can manufacture it, we can fabricate it on in-house in lab as per a requirement.
but this is more like a belt. I sorry, it's as a this is more like
Continuous belt, right?
a
What
chain.
Yogesh is suggesting, it is not continuous.
No, no,
Has
it's
links.
so
I know
it's
it is continuous, but you see, when I say it is not continuous, it is because the bend angle and all, which it is going to do, that is not going to be a continuous one. It is going to be a discontinuous one.
okay,
Not going
right,
to be
right.
good for a. It's not good for a timing belt to have that discontinuity.
Okay,
It has to be a band. Only then it will work very
okay.
good.
The second option the second option I think we can think of is like having silicon rubber and mold it using, make mold using Modella or Shopbot, pour that silicon rubber into that mold, and then we can make our own timing belt, which is continuous in nature.
Silicone rubber is not that strong. No, I think you should try polyurethane plastic with some fibers embedded inside it and see how that goes. I'm interested to know about that.
Okay, PU.
Polyurethane,
Okay,
yeah,
PU.
the polyurethane that is pretty flexible. If it is thin, it is pretty flexible. That can work in this for molding, casting, timing belts. But silicone won't work.
Okay.
Maybe silicone with some fiber infused into it. That also you can try.
Okay, yeah, exactly, exactly. So at the very back end of the timing belt, it should not be
Yeah.
flexible. So we can put a belt, so like of fabric or something, or
Yeah.
or else we can use the clutch wire itself embedded in the timing belt. You got my point?
Yeah, clutch wire.
Clutch
Yeah,
wire,
you
we can
destrand
infuse
it.
it.
Yeah, like not the whole clutch wire, but you can destrand it, and each strands you can place into it. But
Yeah,
again,
definitely.
the silicone again it won't take much force, but I would you can try fabricating it and then I try it out.
Okay, definitely, definitely, I'll do that.
Okay. So what you have to do now is one on the team you have to share the group page. That can be Kavita on the team one because she's remote, and for team one it can be
Yogi.
no. Oh yes, Yogi could be, but I want to force someone to make it.
Shall I?
Oh Yogi, yeah. No, let's do it, Yogi.
Yeah.
So Yogi, you have to be aware what all your mates are making and request all pictures or whatever files you need to make the documentation. and request all the information to your group. And you have to write the group page, apart from designing the deciding the machine and sketching it. Okay? This you will make at minimum. Then in team 2, we said it's gonna be Kavita, isn't it?
Yeah.
Okay. Kavita will make the group page.
This is the page.
Is Vishnu is not there?
No,
It's not here.
it's not present in the lab.
He'll come back.
Is not what? Sorry.
He's not in the lab.
Yeah.
So what about Paul? Like, how will he be graded if he doesn't do this week? Like, he's not involved in anything.
Well, I didn't put this. I didn't put him in any of the groups. And I need to talk to Vinod or Barun to tell me if he is going to continue. I mean, when you don't continue, it's like you have 3 options. Like you will make it later, and no one bothers you again. Like, or you defer for another year, or you say I'm not even interested at all. You can remove me from whatever list you want because I don't even want to receive lists from alumni or for whatever. So you drop out. You have these 3 options, and Paul has to take this decision. If he wants to be drop out, deferred, or it's just he's gonna complete his work later during the year. Same applies to Arsina and dentists so far.
I can get in touch with Paul, see what he says.
From Kochi, Daniel was supposed to do this with dentists, to talk with him about this. But then now he also has to do the same with Arsina. So, I mean, I have 3 people now that I am almost certain that if they continue like this, they are not going to make it. And they are dentists, Arsina, and Paul.
But even if they want to do it later, how are they going to do this group project?
Who, Paul?
Anybody who wants to do it later, this is a group week, right? So how are they going to do a group work later?
Yeah, this no, you cannot do it later because this is a group assignment.
So I was talking about this week's assignment. So this week they have to be here, right? Or else?
Yes. Yes, because when you are going, this group assignment is gonna be due in 2 weeks, and definitely you cannot do this later because when you do this later, it's gone. I mean, you can do poster later tasks, but it won't be like the main task. But you can join later, but because maybe in 2 weeks you don't have it ready, you need to be there.
Okay, but Paul has a 3D printing company, so like he runs it. So basically, everything that is involved in this group's activity is done it already, including building a 3D printer on his own with a team and even selling.
You mean Paul Anand?
Yeah, that's right.
But Paul Anand is not participating anymore, is it? Is him?
We don't know. I'll get a word from him.
Okay. Yes, please. If someone, the last thing I understood is that Paul is not participating anymore.
That might
This is
not be
what I
correct.
understood.
No, won't be accurate. That's not his official statement.
Okay. But yeah, he can even if he is out, I mean, he is not going to update his assignments. If he wants to join one of the groups for making the machine, he can. Where is Vishnu anyway? You know? Anyone knows?
We can call him up. He is in Trivandrum, but he's just not in lab. He might be involved in some other KSUM activity.
Mm-hmm. Okay. So let's focus on this. Then later during the next week, we have to automate the machine. Okay? And we have one problem here. Is that we don't have the motors, but you have some stepper motors in the inventory. I mean, you should have at least 4 stepper motors, don't you?
Yeah, we have a lot of them. 10.
Yeah. 4 will be okay, like 2-axis, 3-axis machine.
Right.
Then the problem is the stages, because they are using Fernet. I mean, we will have a fallback ever, always. Like we can use another thing, but then there is no point for joining the FabAcademy if you make another machine. I mean, you can make another machine. The good thing about being FabAcademy is that they are explaining something that is very, very new, very state of the art. It's making a machine that you don't have to plan it in advance. They are making these stages, these modular stages. They have rotary items, linear items, so you can assemble them later. So you make these stages, like the mechanical stages and the other stages, and you are supposed to be assembling this later. You decide later what is the machine doing. This is one option. If you want to go this option, then you only have to 3D print. I mean, what is the maximum dimension you can 3D print in the
200 by
printer?
200. Yeah, 200 by 200 by 200, I think.
No, the Ultimaker is bigger than that.
Definitely 200. 200. It is 200. I measured. XY at least is 200.
No,
The
Z.
base, it is 200 mm.
Because if you print a square threaded rod, you will need to print it vertically.
Oh, threaded rod. Printing a threaded rod.
Yes.
You can talk.
I don't think that's a good idea to print a threaded rod. To be
Why
very,
not? Why not?
first of all, it will be like a huge waste of material. Secondly, how precise it would be. We don't have, these plastics are like either PLA or ABS, but they cannot withstand mechanical wear and tear. We have to use something like nylon or something, right? So
You mean
for any,
for production?
yeah, like any moving parts should not be made using this plastics like PLA or ABS. They won't stand the mechanical wear and tear. They will get damaged very soon. Only very few plastics like nylon can withstand that.
Yeah, but threaded rod, you mean it will not withstand
Yeah.
the machine? What is your machine going to do?
No, whatever, like if, the threaded rod, something will be moving on top of the threaded rods, right? Some kind of net bolt, something like that. Or even if it is a smooth rod or a bushing made of this PLA or ABS, it will be moving on top of something, or something will be like there will be some mechanical motion, and it's going to wear very fast.
What I would suggest is molding and casting.
Yeah, but
For a
you
like a
can use
bearing,
molding and casting if you want.
Frank,
Yes?
for the bearing part, I was once talking to Yogi about this. So we have barbette metal here. So the metal blocks we have for the metal casting part, that's actually barbette metal. That's a metal which used for making mechanical bearing bushings in old days. So that's a good idea.
Do you know what alloy it is exactly?
It's an alloy of antimony.
Antimony everywhere.
Yeah. Yes, I know that this is not the definitive machine, but what we are training here is your ability to fabricate a machine. I mean, in the future, you will have a machine that will 3D print nylon. I mean, you can also buy nylon filament or whatever you want, but we don't have it now in the inventory. But what we are training is the ability to fabricate something that you don't have. It's not that this is going to be the best thing or it's going to last forever. But what you can design and it can move. And then tomorrow, meaning you are after this, you are working in a company that they have expensive machines, you will be able to fabricate all of this in the proper way. But if you don't have the design skills, you will not be able to do that.
Okay, so Frank, one more thing. Suppose we are printing the threaded rods. How are we going to do that? We are going to print it vertically or horizontally?
He said vertical.
Vertically, will it stand?
You just have to make some modifications so that it stands. When
You will not stand. What do you mean?
It will fall off after some time. Like maybe after 15 centimeter or something, it will not stand it. It's too thin for its height.
But you can decide the size.
Yeah,
I mean, you are not going to make an M3.
sure. Even if you are making something like M16,
it can stand.
Yeah, an M16 will be fine.
yeah, it can stand technically, yes. But what's the point? We can get the parts from old junk items, salvaging.
You can salvage as well and use the 3D printer to adapt the parts that you have
Yeah,
to the motors you have, like making only the connectors. This is a good use of a 3D printer, making connectors. But this you will know when Vishnu is going to tell you what is the machine he wants. Because you don't know yet. Maybe you don't need this and you only need timing belts and pulleys. It depends.
Kavita
Oh, Kavita is here. Kavita, you have been selected to be in charge of the group documentation. Okay. And Sibu,
yes.
The other problem, apart from this, I don't see a problem with that. I mean, this is part of the learning process, like testing these rods or this whatever and making mechanical tests so you see if it works or not and take conclusions. This is part of
Okay.
this of the goal.
Okay, sure. We'll try it out.
Then did you hear yesterday Nadia has made another FabAble
Yeah.
board?
Yes.
Word.
Yeah, another
Huh?
control.
Oh, controller. Arduino?
This? Same.
Yes,
Another board with a different. It's a board that can be made in a Fab Lab
Yeah.
with the
I
tools.
saw that. I didn't read about it.
No, she talked about this.
Yeah,
Oh,
she just no. She didn't mention anything. I mean, I didn't go to the page or anything. I didn't even search for it. I will do it.
maybe she mentioned that during the.
No, no. She was showing some new stuff over there.
Yeah, it was mechanical. I'm not sure about issue or a board.
Yeah, it was in the preparation meeting. During the preparation meeting. I don't know if you were connected.
Yeah, like 1 hour ago. We were connected 1 hour ago.
We were, but we didn't listen properly.
But she was showing a lot of stuff over there.
Yeah.
So, what do you think now then
For
about the board?
the board, okay. I don't know. I designed the or I mean I redesigned the original Gestalt board for and I ordered the components. They are on the way. I mean, like it got delayed due to a lot of holidays. There were a lot of holidays recently, like Easter, Holi. So it got delayed. I should be getting it this week. So I thought I
What
will make
about,
at least one of those boards, Gestalt node, and see if it works.
what about the milling?
What about milling? Ah, okay. So that day I was trying with the 1/100th of a bit, 1/100th of an inch bit, right? So that's not that doesn't seem to work well. So I redesigned the board. I made few traces narrow. I added few more vias so that I can mill it with using 1/64 now.
Everything?
Yeah, entire board using 1/64. And
So you
it's,
don't need any more the 10 mil bit?
no, I don't need that.
That's great.
So it
But
just uses 1/64, and the vias are again drilled using 1/64, and other rest of the things like 1/32. So the board will be milled. The vias will be milled half from top side and half from the bottom side, so they meet in between. And the alignment techniques I'm using there seems to work pretty well.
but what is the point of making the bias with 164?
So that I can make the vias very narrow. If I am using 1/32, the vias has to be like big diameter. Otherwise, during the milling stage, it will just come off. So if I use 1/64, it can be too thin. I just have to insert a single copper strand and solder it, and I can put lot of vias everywhere, wherever I want. If it is too thick, I cannot do that.
Okay. But
Not all the vias are 1/64. Some of them are.
I mean, for the 132,
Yeah.
it's almost unbreakable. I mean, this will last for all forever. If you don't break it, it will last forever, for a lot of time. So you can make infinite bias with that. With the 164, I think I don't like this. This is a very delicate tool. If you use this for making bias, you will wear the tool very fast.
And I'm not making all the vias using 1/64. Only just few of them where it is like where the vias are in a very congested place, nearer to the IC or something like that.
And one another question, Sibu, what was the cost of doing that with the 164? Is in exchange of thinner traces?
Okay. The cost is like I had to make few traces thinner, and some of the traces were carrying power, so that cannot be made too thin. So I had to redraw so that I had to add few more vias so that the traces will be thick enough to carry the power.
Hmm.
Those traces won't carry much power. It's like powering the microcontroller and all, like 5 volt supply, not the 12 volt or 24 volt for the motor. But still, I feel like it shouldn't be that thin.
Okay. Is two-sided mandatory?
Yeah, it has to. Otherwise, it will be like too big or something.
Hmm. Okay, this is because the size of the stepper, because you are using the plug-in thing, isn't it?
No, no, not exactly. Even if I use the IC, it will be. If I use IC, it will be more complicated because IC has a lot more pins than this module.
Okay.
So
Okay.
lot of the reference voltage components, a lot of stuff are already there on the board. So we are in fact reducing the number of pins.
The only thing I'm worried is if the pin will be the same.
Okay, about that, there are slight mismatches. For example, the original board, the chip used in it has micro stepping capacity, but it doesn't go to 1/16th of 1/16th step. But this
Mhm.
the chip I am using, that goes to 1/16th of a step. It can do 1/16 micro stepping. So there are three pins, MS1, MS0, MS1, and MS2, that controls the micro stepping. And the original board has only MS0 and MS1, 2 pins, and the new board has MS0, MS1, MS2, 3 pins. So that's one thing. And original board, some of the pins like sleep, reset, these pins are already inverted. No, they are inverting in circuit, and in this board is already inverted. And there is a different version of the same module which doesn't have this inversion, so it's kind of complicated. So I don't know how exactly what it is, so I left the some jumpers are here and there.
But let's forget about the pins, about the sleep and all of this. I mean, only the movement pins, the 4 pins for
Well,
movement.
yeah, they are the same.
They are the same.
Yeah, they are the same. So
Okay.
basically, the chip takes only two. Basically, they take only two inputs: the direction and the number of steps, and they give 4 outputs for the 2 coils. So they remain the same. Their current handling capacity remains the same. The communication protocol delay, everything remains the same. They are compatible.
What do you mean? Only direction and number of steps?
Yeah.
But not number of steps, like the step rate. You have to fit with the step rate. If you want to give it acceleration,
Yeah, he meant that the PW
who is
or
controlling that? The IC?
pulse.
Yeah, so okay, so there are two pins. One is the direction. So the direction can be either high or low, depending on what it is. It spins on one of the direction. And now
Okay.
this number of steps. So each pulse will move the stepper with one step. So depending on how fast you send the pulses, it will move. Okay, so if you want to move the stepper very slowly, your frequency of sending the pulses will be less. If you want the stepper to go very fast, same thing, higher frequency
Okay.
stepper.
Okay.
So Frank, do you want me to continue with that Ramin's board also?
Which one?
The one which you asked me to make, the Ramin, like the guy who did 2014 FabAcademy with you, and then you guys were working on,
Ah, the running board.
yeah, the
No,
Ramin.
not for the not for the moment. Keep it for output devices,
Okay.
but not at the moment. You are in the other team of Cebu, so I want you to look at this other new board that Nadia showed during the preparation meeting.
Mm-hmm. Does she have a page
Or
for that?
Hey, do you
just
remember the name of that? Did he give any? What's the name of that new board?
I don't know. It doesn't have a name. It's a available version. Like Puneet,
Yeah.
please send an email to Nadia Pick
Okay.
and ask her where is the, because she said he can add this to the repository. Ask her where is the repository with the new board, with the available version. She changed the the stepper driver. So let's see if she put the same stepper driver as Cebu.
Okay, should I send my board also to her? The designs of my board. Just ask
Yes,
her. When,
So
yes,
what
please.
yeah.
okay.
This can be a collaborative thing. You can,
Yeah.
Cebu, when you have ready your documented this board,
Yeah.
you can share this with the class.
Okay.
So the class, they maybe, if you put this in a GitHub repository, maybe they fork it and they improve it further.
Okay.
Okay. So what should I ask? I should ask for a favorable version of Gestalt board.
Yes, yes. Like
Okay.
she mentioned during the preparation meeting, that she had made a different design of the board, a
Right.
Fable version. Carbon copy the class, please, because there are many people interested in that topic. Then, what I want you to do now is to gather the team. I mean, in team 2, if Vishnu is not there and you cannot contact them, let's replace him. I want you to start working. That now you are a lot of people together. Sarat,
Yes.
you decide what is you are going to decide. You are the customer. You decide what is the machine you want to make. What is the maximum cost you want to pay for that, and you have to sketch it and pass it to Punit.
Okay.
Like now. You have to decide. And Yogi, you the same. And Akshay, you the same. Yogesh, you tell Yogesh.
Yep.
In Binyanashram, Yogesh, you tell it to Priya. Okay? So I will ask you later what is the machine you are going to do. Okay, don't make it like a big issue. Like just decide one of the machines, like something that you need or something that is funny. Like maybe can be something. I mean, very simple. Like identify a problem that you see in the Fab Lab, Yogi, Sarat. Identify a problem that the machine could solve, or something that you need for your personal. You are the customer, right? Maybe you need something. I don't know, whatever. But you have to decide it today and pass it today to your. You cannot spend more than this time for this task. Okay. So again, whoever is the team leader, like Sibu, Punit, you gather with all your team and you make the schedule for this week. Like you have to do the schedule. No, how do you say it? You have to divide your work. All the work you need, you have to divide the work and the tasks among all the people in the team. Okay? So the remote people like Kavita and Yogi, you have to be during these meetings. You have to be in permanent contact. You don't have to be all the time in video conferencing, but you have to schedule some meetings with the frequency that you consider this appropriate, and then you can work alone later. But schedule some meetings, arrange some stuff that you have to do in group, and then you work separately. Okay? Yes?
There's I don't know if it will be too simple a thing, but we actually need a electromechanical thing which can control the access of the door which we have to IIITMK. Maybe it must have also an authorization system, authentication system. So I mean it will need some motors and other things to control the locking also. Can that be done? I don't know if I had to discuss with the whole group. If everybody says yes.
Yes, you mean an electromechanical thing that you can open the door? That door, yeah. I see at the back?
Exactly.
The back door?
Yes. I mean, the thing is, it's not a big thing. It'll be, yeah, it's not a machine, but yeah, it'll but have the what? It'll require the motor controls and other things.
Yeah, but it needs mechanical moving parts.
Yeah, because not all the people need to come inside. But if someone else comes who has access to this lab, it should open.
Okay, and how are you going to do the electromechanical thing?
Yeah, it will have some mechanical things which will help to close this door. That is there. Then the other thing is that we all have the ID cards. We can use an authentication mechanism based on that.
But your ID are
RFID. Yeah, this we can use. I don't know if we have an RFID reader here, or we can integrate that.
Or because I had a cardboard one.
Sorry.
I had a cardboard. They didn't give me an RFID.
Yeah, me too. I also have a cardboard.
No problem. Okay, we'll make a fire.
The fellows have the RFID machine.
Yeah, but we can use NFC stickers.
Yeah, we can use
this. That makes sense also. Fellows can be here.
And the other thing is, see, not all people will have to pass through that door. That is another thing. So people who have a valid ID only will be passing through that. So it
And
doesn't
what
mean
is
that
going
all
to be the locking mechanism?
it must have a see.
Magnet?
See, no, it will have some sort of a motor control which can lock it there, which will be most probably kept inside the fab, but it should be operatable from the other side also. So that will be based on the authentication mechanism that we do.
It can
Are
be a
you going to get
Yeah, it is a
permission
very
to
simple.
drill the...
It can be a very simple thing like a motor which will be driving a shaft.
It can be a magnet, just open and close.
Sarat, are you going to get permission to drill that door?
I don't think permission will be a problem.
Yeah, because it is only to IIITMK, right? Because otherwise what we do is we use two separate locks from the other side as well as from this side.
Okay. Yeah, that is a good project. If you need this, it's okay. It's
No,
a
it'll
good
be,
project.
yeah, I don't know, I mean, it'll not be too complex a thing, but it is something which is required here.
Will you call that a machine? But
Yeah, that is a question.
Kavita, I don't know if you hear us. We cannot hear you, but did you hear the machine? You are in charge of the documentation page.
there's no response from Bhumika. You know, but no
Okay.
response.
So you do the same in the other team, Yogi, beside the machine and start the documentation page, the group documentation page. Then all the people start the week 9 assignment.
But Frank, can we call this a machine? The door lock mechanism.
Well, it breaks one of the rules. It must have 2 axes plus an effector.
Oh, okay.
End effector. It should have an end effector and axis, 2 axes minimum.
But
Right.
Yeah, this is only a 1-axis machine.
yeah, only one axis is there.
But I want you to make a 2-axis machine to interact the 2-axis movement, because this is only a binary open-close. It doesn't even have it's 1 axis and not even with acceleration. So yes, it won't be. I won't. I mean, these are personal rules. This is not required. All these rules are not required, but we are going to follow them.
Okay.
Yeah.
So yes, please thinking about another thing.
Another thing.
I know it's not easy, but think about your needs, the lab, or your personal things, because you are Sarat, the customer.
Francisco, one question. So, would a moving robot qualify as a machine, which can then have an effector which does something?
What kind of machine?
A robot which has an end effector and it can move independently. Can that be a machine?
Like a rover or something like this, you mean?
Yeah, yep.
Yeah, it could qualify, but it is a little bit complex later to...
Okay.
I mean, it is okay. If you think you are going to have time to do this during this week, like your mates in Trivandrum, they have to be able to fabricate this on all the components and also belts. This, and by this week they have to make the physical device without motors and be able to move it manually. Next week, automatic. So, but yes, a rover, maybe you can. I think you can. It's a small thing with the laser cutter. You can make a lot of quickly gears, so and wheels and many other things. So I think so. A small rover you can do.
Sure. Okay. Cool. Thanks.
Okay. I'm still missing Daniel in Kochi.
No, I don't think we can. I don't think they'll join right now.
Hmm. Let me have a look at something. Wait, before I go, have 5 minutes. Because when is the end of this? Wait, let me check the schedule. Okay, May 25. Uh, three. What is the Thiru? Okay. Okay. You know what I am looking at now?
You're not sharing the screen.
Ah, I'm sharing. I'm looking at this now because I'm going to probably going to grab some next.
Can you share the screen? Atif joined. Someone from Kochi joined.
Yeah, this. What is the language here? What is the local language?
Hey, are you coming here?
I'm probably going to.
Going-
You're going to be here?
We're coming here?
Yes, I'm going to grab some next. I'm probably going. You should be scared because I might be going there somewhere in May. Mechanical input, molding output. I'm probably going there here or here. Probably here. I don't want it to be too late. So I have a look. Okay, I will have a look when, but definitely I'm going to grab some people by the neck. Yes. Okay. So I will be visiting probably. I don't know how I'm going to make it. To make a whole tour, so I can visit Mumbai, all the people there. But when I come there, it should be for Kochi and Trivandrum. They should be together. Is it possible, like for
For a day or two?
like for the people for Kochi to come there? Is like, how do you usually go from Kochi to?
We travel through train. That is like 5 hours. 5 hours train journey.
Okay.
Actually, somebody from Kochi has joined.
I don't see anyone.
I am here. Atif is there. Yeah.
Hi, this is Atif.
Yeah. Everyone's good.
Atif.
Okay.
Nice to see you. Atif, you in your team, one of you has to be in charge of deciding what is the machine
Okay.
they want. I think it has to be you check the video. It has to be a 2-axis machine. You cannot buy anything. You have to fabricate or salvage anything you want, and it has to be 2-axis machine and something that is not a boring thing, like not a CNC or general purpose milling machine, or has to be something like useful. Like if you get some ideas from past years in Barcelona, they did a pizza cutter. I don't know. There are many things you can think about. Also, you go for inspiration to past years. You will see what they did.
Okay. Okay.
It's a lot of work for a week. Don't know. It's not that a lot of work. You are a group. You have to divide the work. Should be a lot of work for one person, Yogi, but in a team shouldn't be like a lot of work. Okay. So again, I'm going to plan a visit. So prepare the Yam Yam, or what was the Yam Yam? What is the restaurant we went?
Zamzam.
The Zam Zam. Get the Zam Zam ready. Because I'm going. So I will let you know what is the final schedule. I want to visit Bahrain, Vignanashram, Mumbai, and Trivandrum, Kochi. Maybe, yeah, I think the best is going to be that the Kochi team, they come here for that week.
What about Sept?
But, or maybe not. I don't know. Maybe not. I don't have a clue. I will let you know later. Okay?
Sept. Ahmedabad Sept. What about Sept? Ahmedabad.
That?
Yeah.
It's not under my super note.
Oh.
Is there someone?
They are under Israel.
Who's taking Israel?
Ohad.
Ohad.
Ohad is the FabLab guru that is doing Israel Supernode. Okay. Today, remember, today, machine and plan. Okay? You have to decide what machine and you have to make the plan. So tomorrow we have the plan and the machine and the task divided. Okay? So focus on the task for today. Machine, plan, and division of tasks. Okay, so gather with your group and talk about this. Okay, and then work separately and together. Separately and together. Okay?
Okay.
This is what they are going to evaluate. And your documentation, remember, they have to reflect all of these things from the grading criteria.
Okay. Okay.
So don't just say we make that machine. Take a look in the grading criteria and do this. So tomorrow I will review all the plans, the tasks, and the machines. Okay? Because tomorrow we are making another thing. So see you tomorrow, guys. I will let you know later about the planning.
Bye.
Bye.
Bye.